Good day everyone. This is our thesis entitled Techno Economic Analysis of the Adaptability of Solar Powered Rice Thresher in Barangay San Jose, Mabini, Bohol. Background of the study. The threshing machine was a machine first invented by Scottish mechanical engineer Andrew Meikle for use in agriculture. The statement of the problem. One of the main problems faced by the farmers of Barangay San Jose, Mabini, Bohol is the nearest gasoline station is 14 km away from their livestand. They cannot buy easily diesel for their diesel engine, and especially in the pro-harvest time, is the difficulty to carry the rice thresher to the harvest sites. Objective of the study: 1. To present an analysis and estimation of a grid-connected photovoltaic power system. 2. To determine the energy production of the solar panels. 3. To provide techno-economic analysis using the gathered data for rice threshing. This will be conducted in Barangay San Jose, Mabini, Bohol.
Let's proceed to chapter 3, Methodology of the study. Diagram of process flow. The researcher, would do all the procedures in conducting our study. First, data gathering and actual site visitation. Second, record quotation from providers. Third, planning and estimation of solar panel installation. Fourth, techno-economic analysis and estimation, computation of data. Under of this is costing calculation. Fifth, execution and final computation of the gathered data. 6. Summary, conclusion, implementation, and recommendation.
Planning, computation, estimation of solar power installation. This is the schematic diagram. Solar panel, battery, inverter, the motor, thresher, and the threshing mechanism. The gathered data in Barangay San Jose, Mabini. The engine is Kubota RK70S. Computation and analysis using specifications of 6 HP diesel engine. Solar panel sizing. Diesel engine is using the specification of diesel engine, which is 6 HP for 76 watts. The total load in 8 hours will be 35,808 watt-hour. Power needed from the panel is total load times the 1.3, which is the energy loss in the system. Power needed from panel is 46,550.4 watt-hour. For the size of the panel, power generated from the panel divide power generation factor, which is the size of the panel equals 13,571.55 watts. Selection of the motor based on the specification of diesel engine used in Barangay San Jose. Inverters size 4476 watts times 20 to 30% bigger than the total watts of the equipment, which is size of the inverter will be 5 kilowatts. Battery sizing, battery capacity is 12 kiloampere hour. Presentation, analysis, and interpretation of data. Preparation and the technical plan. Adaptability data of price tracing in Barangay San Jose. The price of the Kubota RK70S diesel engine is 30,000. This use costing calculation and techno-economic analysis of the gathered data in Barangay San Jose. The number of days in price tracing in 16 hectares land is 32 days. The total cost fuel for threshing number of days times the cost of fuel times the number of threshing per year. Cost 32 times 304 pesos times 2. Total cost of fuel for threshing is 19,456 pesos. for maintenance of diesel engine in the inflation price. The first cost is the price of the engine, 30,000 pesos. Lifespan 15 years. Depreciation calculation costs 2,000 pesos. For the calculation for the present, we're using the present worth cost method. The present cost after 20 years is 113,307.14. For the rent of the machine, which is 300 per day, the total rice threshing per year is 60 per days. So the total rent of the machine is 19,000. The total cost of the fuel per year plus the total rent of the Thresher per year is 38,656, and the total cost after 20 years is 773,120 pesos. Cost of the total cost after 20 years is the maintenance cost of the engine plus the total cost after 20 years, which is 2,713,600 pesos. Planning and estimation of solar panel installation, the technical aspect of the materials with the two providers, the Bohol Solar and Solar Works. These are the specifications of the solar module and the inverter, which is Solis 5 kilowatts hybrid, and the battery is NPP lead acid with a battery capacity of 400 ampere hour. Calculation of the total number of inverter and batteries to be used. These are the specifications and estimation. In the inverter there are two strings, so 305 volts per string, and it will be multiplied to the demand factor with a total of 385.25 volts, the maximum capacity of each string in the inverter. In the Bohol Solar 335 watts solar panel, open circuit voltage was 40.2 volts. Assume that there are 14 solar panels for the inverter, so there are 7 panels in each string, and equals to 281.4 volts, which is safe because it's not exceed to the maximum capacity of each string, which is the 381.25 volts. So there are 42 solar panels and 14 panels each inverter with a 5 kilowatts type inverter. So 42 panels divided 14 equals 3 hybrid inverters. Specification of the battery, 400 hours, and the total capacity battery is 12 kilo ampere hours. So the number of batteries will be 30 batteries. The PV watts calculator software. Researcher used this software for the estimation of the energy production of the proposed solar photovoltaic system for Barangay San Jose, Mapini, Bohol, with the area of the installation site of the solar panels will be 94 square meter, and the system capacity is 14 kilowatts DC. The researcher used Google Map in the PV box in targeting the specific location solar panel installation. So for the system information, for the system information, the researcher input default settings from the result and set the project as a residential rate of 9.91 pesos or 0.2 per kilowatt hour, which is the energy rated of the Buheco. For the results, simulation results, these are the results. There were results from simulation. simulation of the software estimated the average annual solar radiation was equal to 4.28 kilowatt-hour meter per day. Total annual equals AC energy equals to 16,799 kilowatt-hour, and the total annual cost is equal to 161,280 pesos. Costing calculation of techno analysis. The project of the solar power installation with a span of 20 years. The project cost of maintenance of the ball solar. Project cost 1,069,020. The outputs of the panels is 14 kilowatt. The total energy hour per day is 43.789 kilowatt hour. Inverter, the first cost is 34,000, and there are 3 pieces inverter. And for the depreciation calculation, 102,000 divided 15 years of the lifespan. The inverter is 6,800 pesos. For the present worth cost equals cost after 15 years equals 180,878 for 31 for the inverter. Battery, which is the first cost 16,480. So for the total cost of the battery is 494,400 pesos. The depreciation calculation equals 49,440. And for the present worth cost equals cost after 10 years equals 1,948,496.6. Cost after between 11 to 20 years. Cost after 20 years will be 7,679,347.9. Total maintenance cost for ball solar will be 9,828,722.8 for the solar works. The same methods for but different solar panel wattage and the rate of installation. This is the project cost. The total output of the panels will be 13.65 kilowatts. Energy production will be 42.48 kilowatts. For the maintenance, first cost of the inverter will 34, and the lifespan will be 15 years. The cost after 15 years of the inverter will be 180,878.31. Battery, first cost and 16,480. For cost after 10 years is 1,948,496.59. So cost after 20 year equals 7,679,347.89. Total maintenance cost will be 9,828,779. Costing calculation between solar panel installation and rice threshing in Barangay San Jose. For the rice threshing in Barangay San Jose, it will be the total cost after 20 years is 2,713,600, while from the true providers is project cost plus maintenance cost will be 10,898,042 and 11,002,622.79. For the summary findings and conclusion, after the data gathered, tabulated, analyzed, and interpreted. 1. The adaptability of using solar energy for rice threshing is not beneficial economically in the barangay. 2. The competition in the lifespan of 20 years for usual rice threshing is much lesser cost than using the solar power installation. Recommendation: if you are planning a project using solar panel, it's better to utilize the days and in order to have the return of investments. That's all, and thank you.